Everyone, today we're going to find the inverse of two equations like so. So we're going to find the inverse relations that might be inverse functions. So for the first one, we have a linear equation here. This one's not going to be too bad. So anytime we want to find the inverse of a relation, we swap the x and y, and then we re-isolate the y. Okay. So first, we're going to do x and y's swap. X is therefore equal to 3y minus 7. And now we're just algebraically re-isolating for y. And so that means we have x plus 7 is equal to 3y, meaning that, well, we can divide by 3 now. And so let's say y is equal to x plus 7 over 3. And that means that written in slope-intercept form, y is equal to 1/3 x plus 7/3. Now, you guys can see that's clearly a line, and any linear equation is a function. And so we can say f inverse of x, the inverse function, is this 1/3 x plus 7/3. Again, this function notation is reserved for inverses that are not just relations, but functions as well. And you have to be able to tell if they're a function or not. Okay. For number 2, we have a quadratic equation. Now, if we swap x and y right now, you'll notice that we would get 2 y's. Those won't be easy to isolate. So what I recommend doing is let's write this quadratic equation in vertex form first. Let's complete the square to get it into vertex form. So if you remember how to do that, we're going to factor out the 3 from our first 2 terms. And then we'll complete our square. So that'll be 3 times half of -2 is -1. -1 squared is 1 times 3 is 3. And so to balance that out, we'll subtract 3. And so finally, we get this equation into vertex form, like so. And that tells us that our vertex is at 1 and 7. Right? That might be useful for you later. Now, to get the inverse, we're now going to swap the x and the y, because you'll notice that we have only one y and one x. So now if we swap them, it'll be easy to algebraically resolve for y. So we'll have x is equal to 3 times y minus 1 squared plus 7, right? And now we're just algebraically solving for y again. So let's subtract 7. X minus 7 is equal to 3 times y minus 1 squared, right? Divide by 3. X minus 7 divided by 3 is equal to y minus 1 all squared. Now we'll take the square root of both sides, and so we get the positive or negative version of the square root of x minus 7 over 3 is equal to y minus 1, right? And to finish that off, we therefore get y is equal to, adding 1 to both sides, positive or negative version of the square root of x minus 7 over 3 plus 1. Now, this would not be a function, right? This is merely a relation between the variables x and y. You'll notice that quickly if you try to graph it, you'd get the positive or the negative version of the square root, meaning you'd get something that looks like that, and that would not pass the vertical line test, right? You'd get 2 y's for many of the individual x values, meaning that this is not considered or qualified as a function. So we can't properly use this inverse function notation, but we can say that the inverse of this original relation is this one. And so that's as far as we can go. I hope that helps, and thank you for watching.